There we go. Recording is currently in progress. As always, you guys can feel free to jump in at any time to ask any questions or pose any concerns that you may have. If I've made a typo here, you guys are always welcome to, point it out. And you guys are always welcome to use the annotate feature as well. Okay, today we'll be continuing our series on the organs. I'm a little stuffy right now, so if I sound a little nasally or if I sound a little stuffy in the nose, you guys know why. Okay, but today, as I said before, we're going to be continuing our series on the organs. Last time we did the heart, and today we'll be talking about the lungs. The lungs and the heart are very much interconnected. So the lungs are a good organ to talk about after we just talked about the heart. It's also one of the most recognizable organs in the human body. If I show you a picture of the lungs, you guys are likely able to point and say, hey, look, those are the lungs. What's up, Colby?
And the spine, right? Because if you see like a random spiral bone just in the body like that, you know it's a spine.
Yes, yes. Yes, you're right, Colby. And also the spine and the lung are in very close proximity to each other. The lung sits basically right in front of the spine. And so, usually in pictures of lungs, as you can see here on the title slide, you can also see the spine back here. Okay. Does anyone have any questions before we get started? Like for real get started?
Oh, what? That looks like it's not hollow. That looks like a big fat piece of meat. Not that doesn't look hollow.
Yes, we're right. We'll talk about the lungs. And you're right. You're right, Daniel. The lungs are not hollow. No, sorry, the lungs are hollow. Sorry, the lungs are hollow. And so though they may look like it's just a big piece of meat, there's actually a lot of space inside the lungs, which you might not have known. Okay.
I have a question.
Yes, what's up? You have a question?
Can you, and at some point, not right now, explain how the lungs and heart work together in more detail? Because I have a basic idea what's going on, but not really.
Yes, of course. Yes, that's a great question. Is that Lena?
Yes, it's me.
Okay, right. I can tell just by the sound of the voice, even though your name is different. But yes, great question. I will talk about the exchange between the lungs and the heart like I promised I would. Okay, but let's talk about just the lungs first before we talk about exchange. So the main function of the lungs is that they are responsible for something we call respiration. It is the process of inhale and exhale. So when I do that,
AKA breathing.
right, they're responsible for breathing. The fancy term is respiration. When I when I breathe in and I breathe out, my lungs are doing a lot for my body. And so they're responsible for something we call gas exchange. Gas exchange is the process by which oxygen enters the bloodstream and carbon dioxide leaves the bloodstream. So oxygen is what our body needs to run. The cells need oxygen to keep going, to keep walking, to keep thinking, right? Carbon dioxide is a waste product of cells. They don't need carbon dioxide. They produce carbon dioxide. And so the cells, they have no use for carbon dioxide. So they give it back to the bloodstream, and the bloodstream brings it to the lungs, and then we exhale it out. As you all know, when we are breathing in, we are inhaling air that inherently contains oxygen. And when we exhale carbon dioxide. There are little pieces on the lungs. Yes, we will talk about what these little kind of lines and kind of like little chunks of the lungs actually are. Okay. But the lungs and the respiratory system, they work hand in hand. And so the respiratory system, it warms air and it adjusts the humidity to proper levels for the lungs. If you guys are ever out on a cold day and you guys run very, very hard and you guys breathe in, it may be a little bit painful. It may be a little difficult to breathe because the air outside is so cold that your lungs don't really like it. And so it's important that the respiratory system warms up the air for the lungs. And the lungs also has the kind of like I should say semi job or like sub job of adjusting pH levels in the body and in the blood. If you guys didn't know, carbon dioxide is slightly acidic. It is on the side of a weak acid, and so and so the lungs are kind of responsible for maintaining the certain blood pH in our body, which is around 7.4 if I remember correctly. Let me actually search this up. Let's just see. Blood pH 7.45. Okay, so it says your blood should be between a pH of 7.35 and 7.45. So 7.4 is a pretty good level estimate. Anthony, yes, Colby, thank you for responding to that. Yes, we are talking about the lungs today. Okay. Does anyone have any questions about the function of the lungs? The function of the lungs is pretty standard. I wouldn't be surprised if you guys had already known this. Okay, cool. If there are no questions on the function of the lungs, the last thing I want to point out on this slide is going to be a little bit of a structure of the lungs thing. And really I should have included this picture on this slide, but we will talk about it on this slide. Okay, so if you look at the lungs here, does anyone know which lung is actually the right lung and which lung is the left lung? This is a little bit of a trick question, right? Because you would think that yes, Lena's got it right. And which is actually very impressive. Very well done, Lena. You would think that this is the left lung and this is the right lung, right? Because this is your left and this is your right, right? That would logically make sense. But what is actually happening here is, if you think about it, this lung is like positioned in your human body so that when you're facing out, your right lung is going to be this
It's kind
one.
of obvious.
Oh, it's kind of obvious. Okay.
Yeah.
Maybe it is kind of obvious for you guys, but this was a new revelation for me when I was learning it. Maybe you guys are just significantly smarter than me. But in the diagram, the lung on the left is actually what we call your right lung, and this lung is actually what we call your left lung. And it's simply because of the way the lung is positioned in your body. The lung is positioned so that the actual body of this lung faces this way, faces out. So this is your right lung and this is your left lung when you're looking from the perspective of the individual whose lung this is. Okay. And so what we can see is the lung is not actually symmetrical, which is or it's not like numerically symmetrical. And what I mean here is that if we look here, we can see that there is one lobe right here, two lobes, and then there's a third lobe all the way down here, as opposed to the left lung, which has one lobe and two lobes. You see? Does everyone see how the right lung has 1, 2, 3 lobes, and the left lung has 1, 2 lobes? Isn't that kind of interesting, guys? I know. And actually the reason as to why this is true, I'm not exactly sure, but this just kind of defies the idea that the human body is entirely symmetrical, because it's not. This right lung, it has 3 lobes, whereas this left lung, it has 2 lobes. And so it's something interesting that I thought you guys would possibly be interested in. Okay, let's talk about actual structure here. Oh man, my nose is stuffy. All right, I'm going to clear all my annotations. And perfect. Okay. As I mentioned in the first two bullet points right here, the right lung, it has 3 lobes, whereas the left lung, it has 2 lobes. And I'm sorry for all the red annotations. These are all spelled correctly, if you didn't know. It's because my PowerPoint for some reason is in Spanish, and when I try to change it to English, it doesn't seem to want to cooperate. So let's see. Okay. You see it automatically changes back itself. I'm not really sure why it does that. Okay. As I said earlier to Daniel, the lung is actually pretty hollow. There's a lot of empty space inside the lung. And this empty space is created because the lung is filled with sponge-like tissue. Does everyone know what a sponge looks like?
Yes.
Yes. Think SpongeBob SquarePants, right?
Wait. Can I say something?
Yes,
What-
Daniel,
wait,
go ahead.
I kind of forgot. Like, what is the right lung 3 lobes, left lung 2 lobes?
Wait, sorry, what's your question?
On the notes, it says right lung 3 lobes, left lung 2 lobes.
Yes. This just means that the right lung has 3 lobes, like we mentioned earlier, 1, 2, 3, and the left lung has 2 lobes. 1, 2. It is like it's split up into sections, basically.
Okay.
Great. Okay. Like I was talking about, the lung is actually filled with a lot of hollow space or empty space. And that's because the lung is comprised of sponge-like tissue. When we breathe air in, the air follows a specific kind of path through the lung. So our air enters through our nose and moves to the larynx, right? The lungs are a pink kind of color, Anthony. If your lungs are healthy, they're
Wait.
going to be a certain pink kind of color. Yes, what's up?
I thought they were without blood. They were like, without the blood in the lungs. They're like like gray, kind of. Without blood.
What you might be thinking about is a smoker's lung.
What? Okay, no, never mind.
Yes, the lungs have a kind of pinkish red color. If you weren't aware of that. Colby, yes.
Because if you smoke, it affects the lungs somehow, and then it like changes color, and that's not healthy. So
Yes, we will talk about smoking and lung disease on the next slide. I'm also going to talk about something called pulmonary circulation, which is the exchange between the lungs and the heart, and how and generally in line with what Lena was asking earlier. But when you draw air in, it comes in through your nose. Let's just say this is your nose. Sorry, this is a really poor representation, but the air comes in through your nose. And it travels down your larynx, down the trachea, and it branches off into the lungs. It branches off into something we call the bronchial tubes, spelled BRONCHIAL, the bronchial tubes.
The bronchial.
And after it branches off into the bronchial tubes, the air takes a bunch of little paths. It spreads out into the lungs like this. And let me just do it for the other side too. And so it fills up the entirety of the lungs. So as you breathe in, excuse my stuffy nose, you're actually inflating your lungs with all this air that you're breathing in. And all of this air that you breathe in, it travels down the bronchial tubes all the way down to the bronchioles. And so these tubes, they get smaller and smaller until they reach the alveoli. And the alveoli are basically these little sacs. They're sacs, as I have represented down here. And once they travel
That
down
looks-
to these little sacs,
That kind of looks like a bone.
it kind of looks like a what?
A bone, kind of
Sorry, like a
like a bone.
oh, like a ball. Yes. Yes,
No, a
they're
bone. A
a-
bone.
a bow. Sorry, what?
A bone.
Oh, a bone.
Yeah,
A little
But-
bit,
but
kind of.
but less little sacs. Yeah.
Yes, remember these are little sacs. Whereas the bone is like the bone is very hard. But once it reaches these little sacs, there are a certain type of like vein that we call capillaries inside these sacs. And capillaries are responsible for the diffusion and the uptake of gases. So once the oxygen or the air has reached these sacs and has reached the capillaries, the oxygen will diffuse into the bloodstream through these capillaries, and then carbon dioxide will diffuse out of the bloodstream into the capillaries. Yes, Anthony.
Can a person survive with one lung?
Okay, interesting question.
Oh.
It is difficult to survive with one lung, but you can survive with one lung. Yes, you can.
Okay.
Yes. It's generally not advised. Same way, like you don't want to be surviving with one kidney, but it is certainly possible. People can have parts of their lung removed. And yeah, we definitely see lung removal in medicine quite often. Right. Okay. So once the carbon dioxide has been diffused back into the bloodstream through the capillaries, the lung compresses and it exhales the carbon dioxide. And that's the process of gas diffusion or respiration. Does anyone have any questions on that before I talk about pulmonary circulation?
Wait, like what did you just say?
What do you mean? What did I just say?
Like before you said, do you have any questions?
Oh, I said, so after the oxygen has diffused into the bloodstream, the carbon dioxide diffuses out of the bloodstream into the capillaries and into the lungs. And when we exhale,
Where's
our
the
lungs
capillary?
compress. Sorry, what, Daniel?
Where's the capillary?
The capillaries are tiny little veins inside the alveoli. They're basically like tiny little branches inside the lungs. Is that okay, Daniel?
Yeah.
Okay, cool. So the way that blood travels between the lungs and the heart is something we call pulmonary circulation. If you guys will remember the heart that we talked about last week, it has certain types of, hold on, let me see if I can pull up the PowerPoint from last week. But the heart itself has pulmonary arteries and pulmonary veins that link between the lungs and the heart. So last week, okay, wait, hold on. Lena is rejoining. Last week we talked about the pulmonary artery and the pulmonary veins. So the pulmonary artery brings deoxygenated blood out of the heart and to the lungs. And the pulmonary veins, they bring oxygenated blood from the lungs into the heart. And you can see on this diagram here, the lungs and the heart are very interconnected. They share a lot of the same major arteries and veins. If you guys look carefully here, you guys will be able to see the superior vena cava and the inferior vena cava that we talked about last week. The inferior vena cava being here and the superior vena cava being here. Okay, so after the lungs diffuse oxygen into the bloodstream, that blood is pumped by the heart back into the heart. So let's say the lungs are here, right? You can see the general outline of the lungs out here and out here. These are your lungs. What happens is after the blood in these lungs has been oxygenated, after the oxygen has diffused in, it enters the pulmonary veins. And if you see here, that's what these guys are. The right pulmonary vein and the left pulmonary vein. So the lungs that have gotten the oxygen into the blood, they enter the pulmonary veins through here. Yes, thank you, Daniel. Through these pulmonary veins. And they enter the heart, and the heart pumps it out through the aorta, right? It exits the heart through this big kind of artery. And it goes to all parts of the body, right? We also know that the heart pumps out deoxygenated blood to the lungs, right? And so let me grab a blue pen tool, and we know that again everything in blue here is deoxygenated blood, right? And so when deoxygenated blood comes from the body and it goes to the heart needs to pump it to the lungs, right? So that way, when the heart pumps it to the lungs, it will come back as oxygenated blood. It will come back as red blood that is ready for the heart to pump to the body. And so the process by which blue blood or deoxygenated blood comes through is it comes in through the inferior vena cava, like we mentioned earlier, and it enters what we talked about last week. It enters the right atrium, it goes to the right ventricle, it passes through the tricuspid valve, and it goes through the pulmonary valve, and eventually it ends up in the pulmonary artery. So we can see here, this is one of the pulmonary arteries. This is the left pulmonary artery, and we're going to look for the right pulmonary artery right here, right? So we know that the heart is pumping deoxygenated blood into the lungs through these arteries. And once these arteries have reached the lungs, they branch off into these bronchioles, into these capillaries. And in these capillaries, that's where the diffusion occurs, right? Carbon dioxide, it exits, and oxygen, it enters the bloodstream. And once this blood has been oxygenated, we can see that it comes right back into the pulmonary veins, and it is ready for the heart to pump it out to the body like so. And that's pulmonary circulation. Does anyone have any questions?
No. Yes.
Yes.
How does it get back?
How does
Yeah.
it get back? What do you mean, how does it get back?
How does the blood, like you said that it comes out and then it goes back in?
Right. So all right, so here, hold on. Let me think about how I want to answer this question. Are you asking about how the heart pulls the blood back from the lungs, or are you asking about how the blue blood turns into red blood?
Like you said, when the blue blood comes out, it gets oxygenated by the lungs,
Mhm.
but then how does it get back to the heart?
Right. Okay. So once the blue blood comes in to the lungs, it follows certain pathways. The heart has these kind of like tubes basically that it runs along, and these capillaries are all connected. So it may seem like they're not connected in this diagram, but the blue blood, it passes through the capillaries, and it will just follow the capillaries back into the heart. It's not like the blood is like flowing into the lungs and then it's like shaking around in the lungs. That's not what it's doing. It's passing through these capillaries that are in the lungs, and then it moves all the way back up through these pulmonary veins. I think you might be thinking that the pulmonary arteries are just kind of like dumping blood into the lungs, and then like the heart like sucks it back up. That's not what's happening. It's more like it follows a certain path. It follows tubes as opposed to like the blood just being dumped into the lung. Is that okay, Daniel?
Yeah.
Yes, yeah. Because I think your misunderstanding was that like the blood would just kind of like come out like through the pulmonary artery and then just kind of like wash around in here, right? Is that what you were thinking?
Yeah.
Okay, yeah. So just to summarize Daniel's question, there's not like free floating blood in your lung. Like if you jump, there's not like blood sloshing around in your lung. That would be a significant issue if there's blood just like if there's just like blood washing around in your lungs. And so what is actually happening is that even though these capillaries at the end, they look like they're open, they actually come back and they route back. They're actually all closed off. And so it's genuinely like not very common for blood to just like be sloshing around in your body. It's most of the time it's inside veins, or it's inside diffusal sites, or it's inside capillaries. Right. Okay. Any questions, anybody else? I know Lena was very interested in this. So Lena, I hope I explained it clear enough. Did I? Okay. I think Lena might be away from her computer. That's a little awkward. Okay. All good. If you have any questions, anybody, feel free to ask, even as I move on to the next slide. Ooh. Oh yes, Lena. You raise your hand. What's up?
I don't want to be annoying, but where do you get the images from? Because I think these images, they're really high quality, and whenever I'm trying to find images, they suck.
I just I just Google them. This is not. I mean, I go online and I search up lung structure, and I just find I just find these. Of course, I'm looking for high quality image.
Oh, wait. The question is, how long do you keep on scrolling?
Oh, I usually find a picture without having to scroll. I mean, I know what I'm looking for.
Oh.
I've learned this material before.
Okay.
I've been tested
Wait.
on this. Yes, Daniel.
Nothing.
Oh, okay. But right, as I was saying, this material is like relatively familiar to me, so I know what I'm looking for. When you say high quality image, Lena, do you mean like high quality resolution, or like
Like, like this one. Oh wait, why is it so? This one where it actually explains, and this one where it actually cross sections.
yes.
Do you just go on Google, or are there any other like websites? Because I see some I see this thing. There's a
Right.
website.
Yeah. This image looks like it was taken from anatomy.app, which I'm not sure what that is. I've never been to that website before, but you can find these everywhere on Google. Like if I take you guys right now, so hold on, let me just demonstrate to Lena quickly. Let's see here. Let's just look for lung and heart pulmonary structure, right? And we go to images. And I click on the first one. You see, this inherently is a pretty good image, even though it's from Wikipedia. So that just goes to show how good Wikipedia is. But again, we can see the superior vena cava.
Wikipedia isn't that good.
Well, Wikipedia is an open source, right? So it's not that it's not good, it's just that you have to be careful about trusting what you read, about what you read on Wikipedia. But Wikipedia is a great seed source. I know your teachers will always tell you don't use Wikipedia, but once you get older, you will start to have more teachers that say you can always start research on Wikipedia. Don't use it as your only source, but you can always start with Wikipedia because Wikipedia has so much. I know you guys are young and at the stage where you guys want to be fed truthful information. But once you guys get older, you will be able to parse the truth from what is non-truthful. So as you guys get older, Wikipedia will become a good starting source.
Because when you get to research, you have to if you're doing like opinion writing, then you have to research, then you have to have like more than one source to back up your evidence, or else your opponent won't be able to it will be able to overcome you with more evidence and more sources that relate to the topic and support.
Yes.
Sorry, just never mind.
Yes. Yes. Colby is right there. Okay, but Lena, you can see how this diagram is also pretty good, right? You can see the alveoli here, even though it says pulmonary cap. Oh, that's not what I wanted to do.
Wait, when are we gonna do GimKit?
After the next slide. I just wanted to show Lena that it's that this is a pretty good image too.
Can we do the snow fight?
Yes,
kit?
No, bro.
Yeah, because
Yeah.
I'm gonna beat you. Maybe.
No, last time I didn't know how to recharge,
Yeah.
and then I had snowballs.
I don't know. I stopped playing the snowball mode with you guys because you guys get mad when I beat you all. Okay.
Yeah, because I'm too good at the game.
No, because you know all the answers, right?
Well, yes, I made the questions. So it's a little.
Oh,
Okay.
I thought you
Lena,
were.
did that help?
Yes, because I can't really find the picture. So thank you.
Yes. Lena, also you can always feel free to just like message me in the WeChat and be like, I'm looking for something. Can you explain this? Even if it's like not during class time, you can always just reach out, you know. I'm always happy to help my students. Okay, let's talk about lung disease. And if you want like if you want a class on a specific topic, you guys can always reach out too. And I'll be like, all right, cool, that sounds great. I'll make a class. Okay. Let's talk about lung diseases. Yay. So asthma is technically not really a disease. I don't really think of asthma as a disease, but asthma is serious. It can be serious. Asthma is usually caused by, you know, standard stuff like allergies, sinus infections, but it can also be caused by really strenuous physical exercise. If you guys are running a lot, you guys can have an asthma attack, which is not great. What happens during an asthma attack is that the air passages, like what I mentioned earlier, the bronchial tubes, the trachea, all the passages that allow oxygen to come into the lungs, they become really narrow. They become really difficult for oxygen or air to squeeze through because of a certain.
It's kind of like the heart attack thing we talked about last time, where
Yes.
the oil and stuff build up and stop the bloodstream.
Right.
Right.
Right. It's nearly exactly like that. And there's something blocking the flow of air the same way that there's something blocking the flow of blood in certain types of heart attacks. But asthma is usually pretty treatable. We have inhalers that can relax the like that can pass oxygen through and can relax the type of the type of constriction that we see with asthma attacks. What is more difficult to treat and what is much more scary is lung cancer. And so lung cancer is a relatively common type of cancer in the United States. And it's where cells mutate in the lungs. It's like every other form of cancer where cells mutate. One of the major causes of lung cancer is smoking. Okay. And like Colby mentioned earlier, smoking brings a lot of
It's kind of
harmful.
obvious.
Yes, yes. It is semi-obvious that smoking would damage your lungs. It brings a lot of heavy metals, it brings a lot of really bad chemicals into your lungs. And
It's like,
it ends up clogging the pores in your lungs. It ends up like damaging the alveoli, the bronchial tubes, and the heart. Sorry, not the heart. The lungs start to look a lot less healthy. If you guys look here, I've included a artistic representation of what a healthy lung looks like versus a smoker's lung. Okay. The actual images, if you guys want to go look online, are a little bit graphic. So I didn't want to include a photo of a real smoker's lung because it can be kind of difficult to look at, but this is a graphical representation of what might happen. Anthony, as to answer your question as to why people smoke,
It feels good.
yes, on top of the fact that it feels good,
Feel good. Like the smell. It smells so gross.
yes, I am not a fan of the I'm not a fan of the smell of
So
smoke.
my
Okay.
my
We have 2 minutes, 3 minutes left. So let me quickly answer the question and make one more point. So there is a certain chemical in cigarettes that is called nicotine, Anthony. And nicotine is highly addictive. incredibly addictive, in fact. And nicotine is also present in electronic cigarettes, in vapes, in a lot of other types of inhaled smoke-based drugs. And so nicotine is highly addictive. And it is dangerous. It really is. And on the flip side, do you guys know what secondhand smoke is?
It's when you breathe in the smoke that someone else smokes.
Right, exactly. So secondhand smoke is you yourself do not smoke. So you don't smoke. Like you have never smoked a cigarette, but someone you know smokes.
My neighbor smokes so much.
Okay.
It's because so many of their.
Okay. But as I was saying, secondhand smoke, if you breathe in smoke from secondhand smoke, it is also very dangerous. It can do this to your lungs, just as bad as normal smoking will. And so generally, if you guys are around secondhand smoke all the time, do not be around secondhand smoke. It is just as dangerous as firsthand smoke.
Yeah, because when I went to Las Vegas for my trip, in Las Vegas, like, since there's a lot of casinos and stuff, you're allowed to smoke. And then, like, I can smell people smoking, and every time I smell it, I just hold my breath
Good.
and try to get out of there.
Yes. Secondhand smoke, as I mentioned, it can be very dangerous. If you're around it all the time, you can also be much higher at risk for diseases like lung cancer. Okay. Any questions, anybody? Because we have less than a minute. Okay, if there are no questions, I'm going to end this meeting. If you guys want to play the Gib Kit, you guys can feel free to rejoin. I will reset the meeting and we will run a couple of Gib Kits, okay? Thanks guys. Thanks so much for joining. I hope you guys all learned something. And I will see you back in the room soon. All right.
You sound like a YouTuber.
Yeah, like, see you next time. Make sure to watch this video and this and
Make sure you like and subscribe too.
yeah.
All right. I'll see you guys later. All right, bye guys. Bye-bye.
Bye.